And we're back with the second part of the summative. So if we take a look at the second part of the summative, it's question B here, and it says to draw a graph for the reaction above, including our energy change. So the first thing we gotta do is draw our x and our y axis. Once we do that, it does say our first point to get points here is to label the organizational pieces. So if we do that, we're labeling our y-axis with energy, our x-axis with the time. We're labeling the title for the graph. So if we look at our title, it should be enthalpy of a combustion reaction. If you want to do enthalpy of ethane, enthalpy of CH3CH2OH and oxygen, whatever you want to do, as long as you're giving me some sort of title that makes sense. Once we do that, it does say that we want to label our reactants and we want to label our products. We want to identify exo and endothermic reaction. And we want to make sure our graph is just drawn correctly and we've identified the heat emitted or absorbed. So the first thing we're going to do is we're going to draw our reactants. So we're going to label CH3CH2OH, which is ethane, plus our 3 oxygens. If we're drawing our graph correctly, we know that our graph from the above question 1A, the delta H was negative, which means our reaction should be going down. Once we do that, we should label our products, and our products here are going to be our 2 CO2s and our 3 H2Os. Once we've labeled our reactants, we've labeled our products, now we got to label our energy that we're emitting or absorbing, and we know that we're emitting 1,255 kilojoules per mole that's being emitted right here. Well, since we know we're being emitted and we know that our energy was decreasing, we know that this must be an exothermic reaction. The one thing that I didn't put on this graph that you did have the opportunity of doing if you choose is your activation energy. If you want to put that in there, that'd be wonderful. That does need to happen in most reactions for the reaction to happen, but that's not required for you for this graph itself. So our activation energy, remember, is that energy required to make that reaction happen. Endothermic or exothermic does not matter.